All right, copy the home plate for tonight. Home plate, page 552, numbers 1 through 6 only, and 4 more problems, which are those. Today we're going to crank it up about 5 notches. I'm assuming, as good students of mine, you've been doing your practice, right? Okay. So if I was to give you a individual pop party on Thursday, you're ready for it, right? Let's go. Okay, then maybe tomorrow. No. Woo! Let's go. Daniel for Presidente. Let's go. All right, so once again, page 552, numbers 1 through 6 only, and 4 more problems, which are right there on the screen. All right, get a Cornell note ready. Today's going to go like super fast. Make sure you have a prayer model ready. And once again, like all the year so far, if you notice, I've been breaking down the concepts as much as I can, giving you practice with the foundation, and move on to funner stuff. Yes? Yes. That's what I'm going to start today. I'm going to start you off slow, like that. Tomorrow we can actually crank my pencil. Let's go. I wondered, no, because I loaned it to a student. Thank you. And this one has power. Somehow when I write it, a lot of palms come out correctly. Damn. I could post it on eBay. Yeah, let's go. All right, we got this, yes? Okay. Our objective for today, I can simplify exponential expressions. Once again, I can simplify exponential expressions. So now, we're about to get started with the last 2 modules of the first book of your Algebra 2 curriculum, and it's in regards to radical functions, expressions, and equations. But before we get there, I want us to do some practice with exponential expressions, because that's something that we need to get there. Now, we've been doing some of this work throughout the year, so some of it's going to sound familiar, but some of it, we haven't seen it since you guys were with me in Algebra 1. Some of you weren't with me, so hopefully your course, whomever you took it with, you actually did plenty of practice for this. All right, here we go. Exponential expressions, and here's some flashbacks for some of you. Let's see if you remember. What are exponential expressions? A numerical variable expression raised to a power greater than 1. A numerical variable expression raised to a power greater than 1. A numerical variable expression raised to a power greater than 1. A numerical variable expression raised to the power greater than 1. A numerical variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. No, don't guess. Actually tell your neighbor the definition. Man, you guys know this? Let's go. Examples. We got 2 to the 3rd power, x to the 6th power, negative 3x to the 4th power, and x squared y cubed. All those are examples of exponential expressions. Let's see, the definition says numerical or variable expressions. Well, this 2 to the 3rd is a numerical expression. Look at the exponent, it's greater than 1, so that's why this is power greater than 1. All right, look at this one, x to the 6th. It's a variable expression. The exponent is greater than 1, so the power of this term is greater than 1, and so on and so forth. Pretty simple? Yes, Mr. Q. Non-examples. 2 cubed equal to x, ab squared equal to 12, and negative 3 plus x. The first 2 examples should be obvious. Tell your neighbor why the first 2 non-examples are not exponential expressions. They're equations. However, look at this last non-example. Tell your neighbor why this one is not. So, hopefully you saw that it doesn't have an exponent greater than 1. Does it have an exponent, though? Yes, and it's an invisible one. What is that? Get it? Invisible one? See what I did there? All right, so think about it. What makes an exponential expression an exponential expression? Hashtag that. A couple of them. Hashtag blah, blah, blah. Hashtag blah, blah, blah.
Blah, blah, blah.
Oh my goodness, why you bug? Tell your neighbor a hashtag, please. All right, Doc, 1. Numerical. Okay. Pass someone. Michelle? What is it? No equal sign? Bam. So if it's no equal sign, it has to be a what? An expression. That is correct. Pass someone. Leo. Hashtag powers greater than 1. Yeah, you see how I shorthanded right there? Let's go. Pretty good? Yeah? What's that? Alright, let's move on. Here we go. Something to remember, and all this should be a flashback, and you're thinking like, oh my goodness, 8th grade, I remember they used to get mad at me to step on the grass. I used to be walking on the yard, and all of a sudden I heard somebody whistle, and everybody turned. No? I know. So far away, remember? And everybody froze and turned. They're like, what did I do? Well, actually, only the people that used to get in trouble. Anyway. All right, here we go. So, 2, whenever you see a number that does not have an exponent, any number that does not have an exponent, you always make sure you write a 1. Whenever you see a variable that does not have an exponent, you always write a 1. If you don't do those simple things, guys, let me repeat this again. If you don't do those simple things, once we get started going a little bit faster with the processes, you're going to make mental mistakes. Tell your neighbor what to remember, please. All right, same thing if we have a negative number, remember, add a 1 to the exponent. Okay? All right, other thing to remember, here we go. On the warm-up, look up. On the warm-up, we did something like this. 9 to the 1/2 power, we said we can write that as square root of 9, which is, I'm just going to put a prime power, which is 3, positive 3. However, what is the process of a square root? Look up, please. Is what number times itself, how many times? 2. How do we know how many times? Because it's the number right here. How many times? Twice. What number times itself twice gives us that number? Everybody got it? All right. So what if I gave you this one? Don't say it out loud. All right away some of you said, well, square root. Well, it's not a square root because now it has a 3. This is called a cube root. Cube root of 8. So what is the process? What number times itself 3 times give me 8? 2. That is correct. All right, and copy this next one. Those you weren't supposed to copy, that was just for you to remember, but copy this next one. 16 to the 1/4. All right, we rewrite it like so. Radical, 16 inside, and the little number is called the index of 4. What does that tell us? What number times itself 4 times give us 16, and everyone? 2. That is correct. All right, put that as a mental note because we're going to need that as we go along. Okay? All right, what else do I need to remember? Commutative and property of a multiplication, associative property of multiplication. Really quick, don't copy these. I'm just going to go a little bit fast through these so that you remember what they are. Now, in algebra, I did ask you to show me the property and label it. This time I'm not. By now you should be there. I'm just bringing it back. Here it goes. Mr. Q, what does the commutative property of multiplication say? Well, the word commutative comes from the root word commute, right here, with an E at the end. What does commute mean? It means to travel. So if I gave you the numbers 2 times 3 times 5, and I made those numbers travel, which means move, I can rewrite it as 5 times 3 times 2. I can also rewrite it as 3 times 2 times 5. It doesn't matter the order. That's why we can do that, because it's called commutative. And the product will be the same. 2 times 3 is 6, times 5 is 30. 5 times 3 is 15, times 2, that's 30. 3 times 2 is 6, times 5, that's 30. The product doesn't change. That make sense? All right, also, the next property, associative property of multiplication. Associative comes from the root word associate. And by now, you should be able to be experts at that, right? So, for example, 2 times 3 times 5. Let's say, let's say Clarissa, Daniel, and Angie. Here they are. And then all of a sudden, Angie and Clarissa get mad at Daniel, and they say, you know what? Shine Daniel. There it is. So they get together, they associate together, and they leave Daniel on the side. However, later on, all of a sudden, Clarissa gets mad at Angie, and she says, shine Angie. So then Clarissa associates now to Daniel. Well, it doesn't matter how you associate the numbers. If it's all multiplication, the product remains the same. I start with parentheses. 2 times 3 is 6, times 5 is 30. 3 times 5 is 15, times 2, that's 30. The product doesn't change. Now, am I going to ask you to show me the process? No. This is something that you should be able to do in your noodle. Everybody with me? Yeah. You're going to be able to move these numbers in your noodle so you can do the computations a little bit faster. Okay? All right. So, y'all ready for your favorite stuff? Here goes. Ready? I still remember when I told you this was the 3rd week of Algebra 1. Here it goes. Multiplication properties, product of powers, power of power, power of products. Quotients. Quotient of powers, power of quotients. Copy those tables, and I'm going to go over these one more time. Leave a space for at least one expression. Copy that. All right, before I begin refreshing your memory with these properties, this top row is going to be using variables. The bottom row is going to be using numbers. Okay? But before I do that, I want to revisit this. Look up. Let me show you an exponential expression again. 2 to the 3rd power. We use that as an example. Is that correct? It's called an exponential expression because it has an exponent. The exponent is 3. So what do we call the other number? The other number is known as a base. The other number is known as a base. So those are the 2 terms that we're going to be using so that we can communicate using these properties. Because I'm no longer going to give you definitions. You should know them by now. But I'm going to show them again to you so you can give your definition in your own words to your neighbor. Y'all ready? All right, here we go. Product of powers property says, look up, x to the 3rd times x to the 4th, and that is x to the 7th. Don't say it out loud. Think it through. We're multiplying. What are we multiplying? Exponential expressions. So what would the property say if you multiply exponential expressions of what? Talk it over to your neighbor, please.
In multiplication, so that you add this, but this is used to subtract.
All right, I heard. When you multiply expressions of the same base, we add the exponents. Yeah, this is taking us back to kinder and first grade. Remember when they showed us addition, repeated addition? And then later on in second grade, they're like, well, guess what? That is multiplication. Does that make sense? Yeah, I learned this I think I was 2 years old or something like that. Nice. All right, let's show it with numbers now. 2 to the third times 2. Let's see what you get.
We still add 1, right?
We don't add 1. We write 1 there. No, we don't add it.
No, Carlos, no.
Oh, the exponents. Oh, we add the exponents, yes. No, that's not what you just said. All right, we got 2 to the 4th. Yes? If I ask you to simplify that a little bit further, this is the same as 2 times 2 times 2 times 2, which is 16. That is correct. So some of you are like, Mr. Q, so how are we going to know if we can simplify? Well, if it's not a big expression, and it's something that you can actually multiply out, then do it. That's the rule of thumb. All right, let's go to power of powers. Whenever you see a property that starts with the word power, always start with a parenthesis. Okay? There we go. X to the third, close parentheses, to the 5th power. So, here we go. Look up. Tell your neighbor what that property does, please. And now that you know, copy this. Parentheses 7 to the 4th power. Close parentheses to the 9th power. Simplify that, please. Go. Don't say it out loud. Keep it to yourself. Thank you.
You're welcome.
Yep. When I go through this, sometimes I hear like after school detention.
Oh, no.
Be nice. All right. Let's see. Damien, what'd you get? To the 36th power. Hands, have you got that? All right. So far, piece of cake, yes? Is it coming back? Yes. All right, let's go to power of products. What word did it start with?
Power.
So we open a parenthesis. All right, but check this out. It says products. Didn't we use that term before? Yeah, so I'm going to use these because that's what a product is. So it's x to the third times, but I'm going to change the x to a y to the 4th. Some of you are saying, why, Mr. Q? Because I said so. To the 5th power. And here's the process. Look up. So we end up with x to the 15 times y to the 20. Now look at it. Can I do one more property? No, because these are not the same base. We cannot use product of powers. Yes? No, but I'm showing it here so that people can see that it's the same thing, just with distributed. All right, let's do another one with numbers. Here we go. Let's do parentheses 2 to the third times 3, close parentheses to the 2nd power. Oh my goodness. All right, once again, don't forget the 1 here. Distribute. We end up with 2 to the 6th times 3 to the 2nd. And if I wanted you to simplify a little bit more, then you would multiply it out as is, right? Okay, show me your fingers how come you are with these. Yeah, it's coming back, yeah? Yeah. All right. Now that we're done with multiplication, let's go to division. Here we go. Oh my goodness. Go wait outside for a little bit. Go cool off. Thank you. All right. With variables only, x to the 30 over x to the 7. Look what we get. X to the 23. Okay. Tell your neighbor what happened with that property, please. Okay, give them the definition properly, not just, oh, they subtract. What subtracts? What are we doing? Yeah, very good. If we divide expressions of the same base, we subtract the exponents. All right, do that with numbers. 3 to the 9th over 3 to the 7th. All right. Let's see. Share with your neighbors, see what they got. All right, let's see. Chloe, what'd you get? 3 to the 2nd, which becomes 9. That is correct. Hands, have you got that? All right. Let's go to the next one. What do you notice it starts with? Power. And then we write x to the 30th over x to the 7th, close parentheses, and raise that to the 10th power. Once again, what do we do if you see this? So distribute, we end up with x to the 300 over x to the 70, which is x to the 230. Okay? Let's do that with numbers. Here we go. Parentheses, 3 to the 9th over 3 to the 7th, and raise that to whatever power you want. You're not. My goodness. I'm going to raise that to the 2nd power. So this becomes 3 to the 18th over 3 to the 14th. So since they're the same base, what do I do to the exponent? Subtract. So this is 3 to the 4th. Hands if you agree with that. And if I wanted to expand this and simplify more, this is 3 times 3 times 3 times 3. 3 times 3 is 9 times 3. That's 81. Okay? Show me what famous outcomes you are with properties. Did they come back? Yeah. I thought I remember when we were in class, I said, remember to always keep these in mind because they're going to keep coming back. You're going to be walking to the high school, passing by Donut Avenue. All of a sudden in the alley, they go, you turn, polynomials. They never leave. All right. So, y'all ready? Yep. Okay, let's see how we do. Example 1A, B, C, and D. Damien, can you call Carlo? And don't copy all of them. I want you to copy one, simplify, copy the other, simplify, and so on and so forth. That's fine. Come inside. All right, here we go. 1A is 3 to the 2nd times 3 to the 5th. Let's see what you get. Chloe, pass it to someone. Josh. 3 to the 7th. That is correct. Hands, have you got that? Okay, good. All right. 1B. Pass someone, Josh?
Yep.
Leo. Okay, well, let's do it together. What are the same bases? Same bases. 2 and 2. So that gives me 2 to the what? Times 3 to the 6. Hands, have you got that? That is correct. Pass someone, Leo? Michelle. What do we get? 12. That is correct. Hands, have you got that? Okay. And the last one, D. Pass someone, Michelle? Zap. Cool. Let's start with the 3. 3 to the first times 5 to the 10. All right. We good? My bad. All right. Let's crank it up a notch. Example 2, B, C, and D. Who went last? Zab. Okay. Let's see. Zab, pass someone. Chance. What is the first thing you're going to do when you see this? Unite? No, what is it that we do?
We add.
Okay, close. But what did we say at the beginning? If you saw a variable or if we saw a variable or number without an exponent, we wrote
number 1.
a 1. There you go. All right, here we go. Now, are they all the same base? So this is n to the 0. All right, here goes the first note that we've been practicing all year. I already gave you this little rule. Asterisk, heart, any number to the 0 exponent is? Very good. 1. Any number to the 0 exponent is 1. All right. Go to 2C. We got m times n to the negative 4 times m to the 4th. Chance, pass someone. Zap. What's the first thing we do? Everyone? Put a 1. All right, pass someone. Zap. Ramon. What? M to the what? M to the 5th. M to the? All right, rule number 2. Put a little asterisk, heart, We cannot leave this with a negative exponent. What do you mean, Mr. Q? Well, first, let's write whatever we have in positive exponent. I'm going to write m to the 5th. Question. Do you agree that m to the 5th has an invisible 1 underneath to make it a fraction?
Oh, yes.
Yes, if that's true, then if we have another variable with a negative exponent, we move that to the denominator to make it a positive exponent. So I do this, and this one goes down here and change it to a positive. And there you go. And that's it. We can't subtract the exponents because they're not the same base. Is that correct? All right. Who went last? Ramon, pass someone. Kenzie, first thing we do. Put a 1 on the x. There you go. And then continue. Are they all the same base? X to the negative 7. Could we leave that with a negative?
No.
So therefore this becomes what? 1 over x to the 7. And we're done. Hands, have you got that? Okay, show me what kind of talk you are with this. Yeah, we got this, yes? All right, let's crank it up a notch? Oh, yes.
Oh.
Too easy. There you go. Start with this one. Example 4A. We got parentheses, x to the second, y to the third, close parentheses to the fourth, times, open parentheses, x squared, y to the fourth, close parentheses to the negative 4. All right? All right, Kenzie, pass someone. Ethan, get me started with this part. What do we do here? All right, so this is x to the 8th and y to the 12. Very good. Times. And he said continue distributing the exponent, so this is x to the negative 8 and y to the negative 16. All right? Pass someone? Ramon, what do you do from there?
You combine.
You multiply like bases, all right? So this is x. So what happens to the exponents?
We cancel out.
And we have a what?
0 and 1.
Well, first the exponent.
Oh,
X to the 0 becomes a 1. That is correct. Okay. Times. What else? Y to the negative 4th. Can we leave it as a negative? No. So then we end it with. So therefore, 1 times that is 1 over y to the 4. How are we doing? Yeah? Okay, last one of these, so we can crank it up a notch. Example 4C. Let's see how you do. This is an exponential expression. We got 3 squared times x squared times y cubed times 3 times x to the negative 1 times y to the negative 3 times 2 to the 5th. Who went last? Ramon? Pass someone? Perla. Really? Sit over here. Help her out. Let's see. Who haven't we called on in a while? Carlo. All right, here we go. Why were you outside? Let's see. Why? It's recording so that every parent can hear. Go. Oh my goodness. Okay. Joshua, get us started. What do I do? All right. Look for any number or variable that doesn't have an exponent. So we put a 1. Oh, here it is. Okay. Next, we identify same bases. What are the same bases? 3 and 3. So therefore, that is 3 to the what? To the 3rd power, because we add the exponents. Next. Is there another number? Oh, yeah, over here. But is there another 2 anywhere? No. So I just write times 2 to the 5th. Why is it possible that I'm moving around the numbers in my noodle? Commutative property. That is correct. Next, same basis, x to the 2nd and x to the negative 1. And that gives us x to the 1st. Y to the 3rd and y to the negative 3rd. That's y to the 0. And therefore, this becomes a 1. 1 times that, and we're left with 3 to the 3rd times 2 to the 5th times x to the 1st. All right, show me your friends how come you are with those. Okay, we got this, yes? Is it coming back from back then? Yeah? Kind of, sort of? I know some of you did not practice these a lot, but some of you should recall these, right? Especially that, I think I gave you guys a parte mid-quarter, and I had you actually write definitions and stuff, and you wrote examples by yourself on those tables. That sounds like a good idea. Woo! All right, let's crank it up a notch. Ready? Here we go. Example 7. Here we go. 5 to the 1/2 times 5 to the 3/2. Don't say it out loud. See if you can do that one by yourself. Simplify to lowest terms. Keep the answer to yourself. Chance.
Yeah, give him a chance. Yeah. No, I'm saying like go ahead.
Let me think about it. All right, here we go. What's happening here? Multiplication. Do we have exponential expressions? Yes. Do they have the same base? Yes. What is the base? 5. What happens to the exponents? The add. 1/2 plus 3/2 is 4/2. What is 4 over 2? So that's 5 to the second. What is 5 to the second? 25. Hands, if you got that? Okay, good. Let's do another one. 7 to the 2/3 power times 7 to the 7/3 power. See what you get. Don't say it out loud. Keep it to yourself. Check your neighbor, see what they got. All right, let's see. Nayeli, do we have the same base? So it's 7. So what is 2/3 plus 7/3? 9/3, which becomes 7 to the, did you simplify? That is 343. Hands if you got that. That is correct. All right. Shall we? All right, here we go. Let's crank it up a notch. No, it doesn't stop. Here we go. Let's do parentheses. 5 to the 2/3, close parentheses, raise that to the 3rd power. Oh. So what do we do with the exponents? Tell your neighbor. You distribute, but this is a whole number. Can we make it into a fraction? There it is. All right, so my base is 5. 3 times 2 is 6. 3 times 1 is 3. So this is 5 to the, which is 25. Pretty much, right? Just transform in a different way. You do this one. 2 to the 1/6 power. Raise that to the 24th power. Oh, yeah. Fun stuff. Okay, show your neighbor what you got, please. All right, let's see. Of course she is. All right, let's see. What's our final answer? Jaylene. 16. Hands, have you got that? That is correct. This was 2 to the 24 over 6, which is 2 to the 4th, which became that. All right. Enough of those games. Crank it up. Parentheses, 9 times 36, close parentheses, to the 1/2 power. Don't say it out loud. What we do need, these don't have exponents, so what do I write?
1.
Bam, bam. And now we know what to do, yes? All right, let's see. This becomes 9 to the 1/2 times 36 to the 1/2. Wait a minute, I can rewrite this. This is square root of 9 times square root of 36. So this is 3 times 6, which is 18. Yes? Yeah. All right. Here we go. How about 27 to the 2/3 divided by 27 to the 1/3? Don't say it out loud. See if you can finish that by yourself. We're dividing. They're the same base. Exactly the same. All right, here we go. Jaylene, pass someone? Who? Oh, Jake, go. $27 to the 1/3. Hands if you're up to right there. Can we rewrite that?
Yes.
Jake, continue. Okay, so if these were square roots, that means this is a cube root. 27, that means what number times itself 3 times? That is 3. Hands, have you got that? Okay, good. And last but not least, before the bell, here we go. Oh yeah, time flies when you're having algebra 2. Parentheses, 8 over 27 to the 1/3. I'm going to call on someone. If they got it, we're done. If not, I give you one more. Oh, yes. Who went last? Jake? Oh, you picked Jake. Okay, process. What do we do?
You write the 1.
1 and 1, distribute. So we have 8 to the 1/3 over 27 to the 1/3. And then? Cube root of 8, cube root of 27, and this is 2 over 3. Hands, have you got that? That is correct. All right, so hopefully for tonight, not fortnight, page 552, numbers 1 through 6, and those 4. Enjoy your home play. See you guys tomorrow. And Carlo, behave next time. Thank you. Bye.